missing. So if we go to the next slide. So just a little bit of background. So SEGH was formed in 1971. So we have the 50th anniversary coming up next year. So we have a number of celebrations planned, amongst them a series of review papers that are being written by the fellows of SEGH and with early career researchers, and those will gradually be released over the coming year. We also plan for a number of meetings, including conferences. So the conference in Kenya that should be happening now has been postponed to this time next year. And we have a workshop planned for August in Vancouver. And we'll no doubt arrange other initiatives for the following year. Yeah. No, not, sorry, slides moved on. And so SEGH was set up to connect a range of scientific fields and disciplines across national borders, as well as linking a variety of disciplines together. You can find information about the society at segh.net. There's a range of information there about us, and also blogs about work that members have written about, so nice news stories. So please do feel free to submit any of your own news stories. We're always looking for new content for the website. We have a early career researcher group which started back in 2018 at the Victoria Falls Zambia conference, and this is gradually finding its feet as the early career researchers form themselves as a group, and some initiatives which Olivier Humphrey and Daniel Middleton will talk about next. And we also have our official journal, Environmental Geochemistry and Health, and the new impact factor is going to be released today actually, but I haven't got the new number, except I'm told it should be positive. So I'm waiting to hear from Springer later today. And that's quite a valuable resource for the society, particularly if we have special issues from conferences and meetings. And we have a number of the SEGH board and members as associate editors in that position. And we're encouraging early career researchers to gradually become involved in that task to gain experience. And so next slide, please. So we are in this situation with SEGHLive due to COVID-19. So obviously we couldn't travel to Kenya, so we decided 5 or 6 weeks ago that we should try and do something online. So this is a first, so we've been learning our way as we try and put this together. So many thanks to Olivier Humphrey and Daniel Middleton, who have been a massive help in putting these slides together and communicating with many of you registrants and speakers, and also to Anthea Brown, who is the membership secretary and treasurer for SEGH, who has been coordinating payments and linking up with registrations and promoting the meeting. And in particular, Adipo Asano and his team in Kenya, who were organizing the conference in Kenya this summer. We couldn't have put this together so fast without help from them. They already had a cohort of abstracts for the conference, which we tapped into. So many thanks for them for collating that information. And then we've invited some other speakers just to broaden the range of the topics and the geographic reach. And also thank you to the international board of SEGH, particularly the newly elected board, who we met for the first time last week via Zoom webinar, and for their support and ongoing ideas for initiatives. Next slide, please. So the format for SEGHLive will come with 12-minute presentations, as you'll see on your programs that we've sent around in the proceedings. So the 12-minute presentations will have 3 minutes for questions straight afterwards, and they are introducing each section. The majority of talks are 5 minutes, and what we'll do is run these in batches of 3, so there'll be no delay between presentations. They will roll straight into the next presentation, and we will allow 10 minutes for questions at the end of those 3 5-minute talks. Okay, so just a little bit about how to ask questions. Many of you will be familiar with Zoom, but we'll just revise what to do. Can you please use the Q&A icon at the bottom of your screen to submit a question to the panel, and then we will direct the question to the speakers. Okay. And if you can do this before the end of the presentation, it will help the flow of the meeting. If you would like to ask a question direct to the presenter, please use the raise your hand icon at the bottom of your screen and the panel will connect you. If there are some technical issues with connections, we may have to move on. So if you really want your question to be asked, the best way is to use the Q&A icon. Next slide, please. So if we have some technical issues, if you are having some technical issues as speakers, please let us know in advance so that we can try and readjust the schedule. Don't wait until just before your talk, and we can try and fit you in later if we can. If we cannot reach the speaker at the start of the presentation, we'll try and do this within 1 minute, and if we can't solve the problem, we'll move to the next speaker. And again, we'll try and fit you in later in the schedule if possible. So we do have one speaker that we don't have slides for, and that's the third presenter, Camilo Priscilla Mercado. So we will be skipping that presentation and we'll go straight through to the following talk. So we will be running slightly ahead at the beginning to try and get ahead, but no doubt we'll use that time. And hopefully you have a good experience. This is the first meeting, so hopefully it works well and there is demand for another one. We certainly have enough talks. There's certainly plenty of demand from presenters to give talks, so we could easily run another one of these if there is demand from the audience. So we will gauge your thoughts tomorrow. So tomorrow we will be starting in the morning to capture talks from Asia, and then we'll have the annual general meeting for the society at the end of the session, midday. So we'll try and gather your thoughts and ideas for any future initiatives for the society. So I hope you enjoy your range of talks, and I'd like to pass you over to Daniel Middleton and Olivier Humphrey, who can give you a little bit of information about the early career researcher initiatives.
Hello, welcome everybody. It's great to know that so many of you are there, and I hope this event runs really smoothly for everybody. So I'm going to spend the next 10 minutes just talking about the ECR community within SEGH, and I thought I'd begin by defining ECRs. So early career researchers are defined as undergraduates and postgraduate students. Right. Or as research scientists who have received their highest degrees within the past 5 years. The Early Career Researcher Group, it was established at the 34th International SEGH Conference at Victoria Falls in 2018. And the idea behind this was to give the early career researchers within SEGH a sense of community, offer up some form of mentorship, provide early career researchers a role within SEGH, and also start exposing these early career researchers to review process and editorial processes in line with the official journal of SEGH, which is Environmental Geochemistry and Health. At the moment, the ECRs currently make up around 20% of all SEGH memberships, and this is a demographic we're looking to develop and grow. So, as I mentioned, the ECR group was formed in 2018, so it's very much still within its infancy. Yeah, I think we've started to make some real progress and some strides. So this year, myself and Dan Middleton led on a ECR editorial, looking at what SEGH can do and how it can build for the future of ECRs. As you can see, this is now got a DOI and will be published very shortly. Within this document, we really wanted to outline 3 pillars which made SEGH ECRs a really welcoming and prosperous community to be engaged with. So we outlined that SEGH is a very welcoming community, and what we mean by this is when you go to much larger conferences, you can often be you can often feel a bit out of place and not quite feel like you're getting as much as you can, whereas at SEGH conferences, there's often between 100 and 200 people, and with the emergence of SEGH fellows, it's now an incredibly welcoming community, and there's always someone there to help you if you're struggling at these events, and you always, if you get the opportunity to present your work, which often at much larger conferences like EGU, ECRs are very much an overlooked group within these conferences. Something else that SEGH has done particularly well in the past 2 years and would have continued doing at this year's conference if it wasn't postponed was training and development. At the 34th International Conference, there was a whole day dedicated to training and career development at the conference. This included exposure to R for statistics, GIS programs, how to conduct a review as in the eyes of an editor, ethical training, and this is something that we as ECRs outlined in this editorial as something that we'd like to see continued and improved upon. Finally, as ECRs, and myself in particular, I view this community as a real pathway to publication. And what I mean by this is the ability to use the website to write blogs about your work and effectively communicate your science to a wide range of people. In addition, actually publishing journal articles and getting involved within review for the official journal of SEGH. Some things we outlined for future, for the future of SEGH ECRs was potentially dedicated ECR sessions at conferences, organised and chaired by ECRs. Potentially an ECR special issue in the official journal, Environmental Geochemistry and Health, with papers contributed and peer reviewed by ECRs. More visibility for the Early Career Researcher Best Paper Award from our official journal, which is hopefully something we'll be able to announce within SEGHLive. And then finally, ECR-led initiatives which give a greater value for money for your SEGH membership. And this is something I'd really like to build upon now and encourage other ECRs to get involved. So how can you get involved with the ECR community at SEGH? Use the website, Twitter, email. There's enough contact information online to get involved and ask someone at SEGH for help or how you can become more active. Being active is incredibly pivotal for actually getting something out of the SEGH community. We're not telepathic, we can't just read your mind. If you want to be involved, you're going to have to speak up and come to the board or send an email or tweet via the website about something that you think that you want or think that SEGH would benefit from. If you come to the board with any ideas, you'll be met with a full support. I'd like to stress that being active as an ECR in SEGH is very easy. Whereas with much larger societies, it's very difficult to get on the board. There are 3 early career researchers on the SEGH board. So hopefully this change is really coming from within the society, and SEGH is being looked at, hopefully can be looked at as a really prosperous community for early career researchers. Potentially one example is hosting a SEGHLive event purely for ECRs, where a group of ECRs can get together and organise and lead on one of these events. The more you put in as an ECR, the more you put into this and developing your network within a great society like SEGH, the more you're going to get out. So I think that's all I'd like to say about the ECR community within SEGH. If Dan Middleton's got anything he'd like to add, feel free.
Hi everyone. Thanks Olivier. That was a really, really nice summary. I think the only thing I would do is just reiterate that because we are such a tight-knit society, there's a big opportunity here for ECRs to really get involved, within the kind of running of the society as well. I think I attended my first conference in 2014, and I attended my first board meeting in 2016. So there's really opportunities there if people are interested in getting involved in managing the society and doing events. You know, it's a great one to get involved with early.
Okay, great, thank you. So we're ready to jump into the program, and we're slightly ahead of time, so it gives us a couple of minutes just to get ready. Hopefully those early career researchers amongst you, if you're not already part of that network, what Olivier and Dan have said will interest you. We do have people from all over the world involved in that network. So we're just getting the first talk ready. So the first talk, we have a slight change in presenter. So Séverine Cornillon was going to present. She's unwell, unfortunately. And Mark Cave stepped in to give the presentation, although he put together the presentation with Séverine, so hopefully it's a smooth transition. So we'd like to invite Mark to get ready. We'll just pull him up on the screen.
Hello, I'm here.
Okay, so I think we can hear Mark okay.
Can you hear me okay?
Yep, you might just need to speak up a little bit.
If you can increase your volume a little bit, that'd be great.
Yeah, okay, hang on a second. How's that? Is that better?
That's better. Wonderful. Great. So the first talk. So we will have a few minutes for questions after Mark has spoken. So do think about any questions during the talk and present them to us. We'll have a little bit of time to go through those. So Mark is going to talk about open web mapping applications to visualize and interrogate environmental data in Western Kenya. So if you'd like to take it over, Mark.
Okay, thanks very much, Michael. It's a bit of an unexpected privilege to be giving this talk today. So as Michael said, this talk was put together by Séverine with inputs from me, but I guess probably the real hard work was done by the rest of the team here, who organised and collected and analysed these samples that we're going to talk about during this meeting here. Okay, so can I have the next slide, please? So just to give you some background to this and what this project is all about, it's looking at source apportionment of micronutrients in diets from Tanzania and Kenya, wider health issues, geochemical, agricultural, pollution pathway investigation to better understand dietary intake exposure. So there were 50 sites in Tanzania, which I'm not going to talk about today. It's the 450 odd sites in Kenya that we're going to look at today. And from those sites, the collection of soil samples, but there was also crops, drinking water and urine samples. And it was also used to strengthen the capacity in the field labs with local staff. So this talk is going to be really about the properties, the geochemical properties of those soils. Okay, can we have the next slide, please? So how did we do it? Well, we've got our 455 samples, and we've got our geochemical and other properties of the soils, and we want to try and produce a spatial distribution essentially to map those soils. So we're doing some interpolation between these sampling locations, and we decided to go down the route of random forest, which is a machine learning method. Maybe in some instances people would have used a Kriging methodology, but recent work has suggested that random forest can work equally as well and have some advantages over that method. So that's why we went down this route. We used two different routes. I worked in the R programming language and used that part of the R language, the random forest packages in that to do the work. And predictor variables came from two sources. These were using inverse distant weighted predictions. These were done at a number of different inverse powers and different numbers of nearest neighbors. And we also used nearest neighbor data and distances as well as our predictor variables. Now, Severine, she worked in ArcGIS. She used the ArcGIS Pro software, which has random forest modeling built into it. And she used slightly different predictors. She used sort of the geographical predictors, which included things like elevation, rainfall, distance to urban areas, distance to major rivers, distance to water bodies, districts, and other soil parameters. So those are the two different approaches that we used, and we wanted to see whether or not we were going to get similar results. So next slide, please. We got the next slide. Yeah. We looked at a whole series of chemical elements, and we looked at pH and organic matter, all of these which have been measured in the soil samples. And we produced a generation prediction grid. It was a 900 meter spatial resolution in R and 90 meter spatial resolution in ArcGIS. The difference between those was just the computing power that we had. ArcGIS was able to work on a higher spatial resolution. Okay, can I have the next slide, please? So this is the most interesting part. We got some actual comparisons here. On the left-hand side, this is the R predictions. On the right-hand side is the ArcGIS predictions. And you can see immediately on the right-hand side, because they've got higher resolution, you can see a lot more features in the data. And also because it's based on things like elevation, distance to rivers, you do see a lot more structure in the data than you do using the R methodology. But you do get some, like you can see in the sort of middle section there are some sort of circular predictions, which maybe because of this sort of distance to measurements are sort of dominating and maybe giving us these sort of some lines and artifacts between the two. But in general, the two agree pretty well where we've got high pH and low pH. But it's interesting that there are some differences between the two. Next slide, please. Have we got next slide?
It looks like Olivier's laptop may have crashed. Mike, have you got the slides?
Oh, I see. He's frozen. Oh, he's back. Joys of technology. Okay. So this one's showing organic matter. And again, actually, these are quite fascinating, and you can spend quite a lot of time just discussing all these different distributions. We haven't really got time here, but mainly what I'm showing is that the two different methods have give very similar results. These results are, they're given in deciles, so they take the prediction and break it down into the 10 deciles, which are then colored up, and then it shows the distribution for each of the two. But we're seeing the same sort of differences between the two. In general, the same pattern, and possibly with the ArcGIS side of it, you may see some more detail, and we've got to check, sometimes it looks like a sensible detail, and sometimes it may be some artifact of the methodology we're using. Okay, can we have the next slide, please? So I think we've got some metals data to look at as well. Have we lost Olivia again? There we go. So this is aluminium. And again, we can see that in general, there's pretty good agreement between the two. There's obviously some smaller differences between the different models. But the nice thing is that we are getting very similar outputs from both of them, given that they've got sort of very different sets of predictors. That's sort of very helpful to show that we're sort of cross-validating the data between the two. Next slide, please. Copper, some slight differences here. Again, maybe this needs to be investigated in. I'll have the next slide, please. Iron, and again, very similar patterns, and we're seeing this similar sort of differences between the two, but in general, a good agreement between the two. Next slide, please. So in both cases, we're getting pretty similar results. There are some differences between the two methods, but the nice thing is with both methods, we're now beginning to see producing these maps, which then hopefully will go on to be useful in the future for the local farming communities, and maybe for also health monitoring applications as well. Next slide, please. One of the interesting things that we can do with this is the output from the ARC method, is that it tells us which of the predictors are important for different parameters. So in this one here, that pH, this one at the right-hand end is the one which is most important. And if you sort of look down at the legend at the bottom, that one is actually elevation is the one that's driving the pH mostly. Next slide, please. And this one is looking at organic matter. And again, elevation seems to be very important in driving the organic matter content of the soils. Next slide, please. This is iron, and it's the actual parent material, which I guess is not surprising in terms of driving the iron concentration in the soils. Next slide, please. Copper prediction, that's the landform is the most important one for copper. Next slide, please. This is aluminium, and this is elevation again, seems to be the important one for aluminium. Okay, next slide, please. So in our next step, what we'd quite like to do is produce some sort of combination of these methods to get the best of both of them out of there. And now Severin wants to go on and produce some nice data tools which can be used put together in ArcGIS, but can be used online and sort of free to use, and people will then be able to query them for various different aspects. It may be these other properties. Well, let's go on to the next slide and have a quick look at what this might look like. So this is Severin's mock-up of what the web tool would look like. So we have a number of layers in it with various different aspects, things like geology, and we could then add in the soil parameters as well. Next slide, please. It's just showing you how you could zoom in on a particular district. Next slide, please. Again, another district there we could zoom in on. Next slide, please. And then maybe we could look at some other parameter, for instance, landform in here. So that can be a very useful end point of where we're getting to with these different mapping processes. Next slide, please. So again, another property there. Next slide, please. Okay, so we're coming to the end here. So what we've really managed to arrive at here is interpolation. That's the real key thing that we've got out of these. We've got these rather nice maps, which is giving us a nice overview picture of what's going on. And the two different methods are sort of cross-validating each other. We hope to perhaps bring them together and produce an even better output from these. Overall from this, we're going to hopefully produce some really nice maps which will go on to be very useful for the local community in Kenya. And with that, I think I'll complete. Thank you very much.
Thanks, Mark. That was a brilliant talk. We've got a little bit of time for questions, and I can see quite a few popping up in the Q&A. Just to remind everybody that you can upvote questions in the Q&A panel if there's one that you particularly like, and that will help us choose those if there are a lot. So I've got one here from Alex Stewart, which is, Mark, interesting comparison between the two different modelling approaches. Similarities towards the southwest, differences largely in the northeast areas. Any ideas why?
I think in the northeast areas, probably we don't have as many samples. So we're sort of, I think we're trying to extrapolate outside the model, and the two probably are doing it in different ways, as I suspect. And one of the things we need to look at is how good the two different methods might be extrapolating outside of the area where we've got samples.
Okay, I have another one from Saeed Ahmad at University of Nottingham. Hi Mark, great presentation. You said that organic carbon content and some other parameters varied with elevation. Please could you explain what the reason for this is?
Absolutely. These are very interesting things. Actually, we haven't got round to really thinking about why these are controlling factors. And probably some of the geochemists who are much more familiar with the Kenya soils would be a much better person to ask. But it's very interesting that we can see these how different parameters control different parts of the things like a very general thing like elevation has such an effect on the soil parameters. Sorry, I can't, I've sort of bypassed that question a little bit because I haven't gone into, looking at that side of the interpreting the data that much yet, but that's something that will come.
Okay, I have one from Chao Sheng Zhang in Galway. Mark, very nice piece of work. Maybe you can't answer this one, Mark, but it says advantages and disadvantages of the two interpolation methods. Which one do you recommend?
I think what we've seen is they both have two, both of them have their advantages and disadvantages. And I think what we really want to do is combine the two together. And I think we will get an even better product from that. I don't think, I think this is still quite new what we've done. So we haven't really understood all the ins and outs of the differences between them. I think if we can combine them together, we will get an even better output from that. I'm not sure whether that is a question or not, but anyway.
Okay, I'm going to try and squeeze one last one in because it's the last one from Marcello Di Bonito. Would it be better to compare when you have the same resolution, and can you look at the influence of other elements in the geochemistry?
Absolutely, it would be better to compare if we've got the same resolution. There were just computing aspects that the ArcGIS was set up much better to deal with the high resolution. When you translated that to my normal computer, it was just a bit too much for it to use. So we're going to look into being able to do them both at the same resolution and compare them. What was the other part of the question?
It was looking whether you can look at the influence of other elements.
Well, we were just looking at individual elements anyway. In order to do it and to predict, you need to know what an element is at the unpredicted areas. So it's not so easy to do that. But we can look at, we will be looking at relationships, you know, between the maps and which elements map in a similar way.
Okay, wonderful. Thanks, Mark. I'm giving you a round of applause and handing back to Michael, who's going to introduce the next speakers.
Okay, thank you very much.
Great, thanks very much, Mark, for the opening of the first SEGHLive event. Thank you. So we're going to move to our next speaker. So I'll just remind everyone that we're going to run 3 5-minute talks. There'll be no questions, sorry, 2 5-minute talks. There were 3 planned. And we're going to do them back to back and then have some time for questions afterwards. Okay, so we're going to start with, I do apologize if I pronounce your name incorrectly. Do correct me. The Jimbili from Mali. I'm afraid I made a mistake of putting France on the program, so I do apologize. So you are from Mali, optimizing soil fertility management decisions in Mali by remote sensing. So yeah, go ahead, please.
Okay, my name is Geneva Dambele. I'm from Institute of Rural Economy of Mali. My presentation is about optimizing for soil fertility management decision in Mali by remote sensing and GIS. Next slide, please. Next slide. Okay. The objective was to assess the use of remote sensing. Why? Remote sensing and GIS in soil fertility decision. The special objective was to use remote sensing and GIS to delineate soil units and to map the levels of pH, NPK, and carbon using soil analysis result and GPS data. Next slide, please. Okay, this study was done at Sikidolo in Mali. Sikidolo is a village in Mali. Next slide, please. Georeferenced soil sample was done using ArcGIS, Landsat image, and GPS. This figure 2 shows the sample's location on Landsat image. Next slide, please. Laboratory analysis of soil sample was performed, and kriging method was used to produce pH, NPK, and carbon maps. These maps was overlaid to produce a soil fertility map. Next slide, please. The results show here the spatial distribution of soil texture. It was soil texture comprised loam, loamy sand, sandy loam, and sand. The sandy loam area occupied the higher space. Next slide, please. This figure 4 shows the spatial distribution of pH in the village. It was between 4.7 and 6.1. which mean acidic soil in the area. Figure 5 showed a spatial distribution of soil organic carbon. It was between, the percentage of soil carbon was between negligible and 0.4, which mean also very low soil organic carbon at the site. Next, please. Figure 6 here showed a spatial distribution of total nitrogen. It was between 0.01 between negligible and 0.023%, which mean also very low level of total nitrogen. Figure 7 showed a spatial distribution of available phosphorus at the site. It was between 2.2 and 5.5. It means also very low level of soil available phosphorus at the site. Next, please. The figure 8 showed a spatial distribution of exchangeable potassium at the site. It was between it varied 0.01 and 0.07. It means also low level of exchangeable potassium. We know that all these the levels of this nutrient, according to the soil, water and plant laboratory, is below the critical level, which means very low soil fertility status in the site. So we try to know where is very high than we try to discriminate the low, the extremely low from very low from low in the area.
1 minute warning, Jemba. 1 minute.
Okay. So we overlay this data and we produce the map of soil nutrient status. So the level was very low in the area. Very low status was generally in the area. Next, please. So in conclusion, the integration of remote sensing, GIS, and conventional georeferenced soil sampling facilitates the mapping of the spatial distribution of soil, physical and chemical property. Soil are generally sandy and acidic. The inherent content is the inherent nutrient content was very low. Thank you very much. Thank you.
Thank you very much. We'll move straight into the next talk. If you could just stay around, we will come back to questions and present questions to both speakers. Okay. So we are currently missing the next talk from Kumbelo Priscilla Mikado. So we will jump straight to Lanyan Timitupi, if I pronounced that correctly, who will talk about ecological and health risks associated with emissions of lead in soils, sediments, mine tailings, and plants in an artisanal mining environment, northeast Nigeria. So just as a reminder, we'll take questions for both of these talks afterwards. Okay. And over to you for the next talk, please. Thank you. Yeah, we can't hear you. Please, can you make sure your microphone is okay? Still can't hear you. You are unmuted. Okay. Well, what we can do whilst we're working out a technical issue there, we can perhaps go for any questions on the last talk. So we'll change the arrangement whilst they're just getting ready in Nigeria. So do we have any questions, Daniel?
No, we have no questions. Just to remind anybody, if they want to ask directly, they can raise their hands in the participants panel or post in the Q&A. I actually have a couple of questions of my own, though. I was wondering if you could tell us a little bit about the remote sensing data sets that you used to extract the soil properties.
I use Landsat image.
But anything in particular, I mean, I wanted to know what you were able to deduce from these images that would tell you about the properties that you were interested in.
I use a Landsat image to stratify the image, and according the size of the unit on the image, the unit according to the size of the unit, I chose a number of samples that I can I can take for analysis. So after analysis, I use the physical properties, and I also use soil texture. I use the analysis to do it. Image is used also to stratify and to choose the samples location.
Okay.
And I took the samples and analyzed at the laboratory.
And these are subsequently analyzed in the lab. Okay. No, that's great. I've got another question which has just come in now from Aki Olatunji from Ibadan, who says, what is the role of geology on the soil type and chemistry?
Geology? I didn't get the question. What is the?
So he's asking what the role of the geology, so the underlying rock formations are on the soil type and soil chemistry.
Okay.
Or perhaps this was something that you didn't specifically.
I think that is soil type or soil type as a link with soil geology, and the type of soil depend on the type of rock or of the type of rock.
So I have another question here from Adam Sadiq, which is why the Landsat image was used and not other images like ASTA? I'm not sure.
Because I had Landsat, I did it. Also, I used also ASTA to do to generate the levels of the altitude levels in the area. This work was done in the context of my thesis. This is also a small part of the work.
Okay. Thanks, Jem. But I just heard some sound from Lanian. Are we?
Hello, can you hear me?
Okay, brilliant.
Okay. Hello, can you hear me now?
Yeah, we can hear you now. Thank you.
So, sorry for the itch. Like I was saying, my work is on ecological and health risk associated with emission of metals on soil sediments, mine tails, and tailings and plants of Faro for artisanal area. Thank you. Next slide, please. So these are the outline of what I'm going to present. Next slide, please. Now, the introduction. Artisanal mining, as we all know, is an illegal form of mining, and it brings a lot of public health challenges. And while mining, especially gold, in this particular area, it emits certain metals with it, such as arsenic and lead. And this had led to series of carcinogenic and non-carcinogenic diseases because of the way it contaminates human being through ingestion, inhalation, and contact risk. Many work has been done on it, but this particular one is on the ecological and the health risk assessment of lead metals in the area. Next slide, please. So these are the aims. The aim is to check the impact of lead on the soil, stream sediments, and mile tailings with the plants. And the main problem is anthropogenic on the area, and this one leads to exposure of lead to that actually affects both adults and children, especially women. Next slide, please. The study area is in Arufu. It's a village in the northeast Taraba state, and Arufu it's in the mid-Benue Trough, which has a locality of lead zinc mineralization. It has a vegetation of Sahana wood type, and it has the annual temperature is within 30 and 35 degrees centigrade. This is the map of Arufu. Next slide, please. Now, the materials, 56 samples were picked, 30 soils, 10 stream sediments, 6 rocks, 5 mine tailings, and 5 plants. All were analyzed, and the top soils were gathered, since we are actually looking for the pollutant, the environmental pollution, to see the effect on the area. And all were that the soil samples, especially the plants, they were air dried and digested. Then all were analyzed using this the high performance chromatography, inductively coupled plasma mass spectrometry. Next slide, please. These are the equations used to check on the pollutant rate of these metals on all the media that has been used, on the soils, on the stream sediments, the plants, and the rock. Next slide, please. Now, the result. From the results, this table showing, comparing the result of the soil, stream sediments, and the mine tails with the USEL and lead has a very high concentration. It is high. It is very high to the permissible limit. And for the rock samples showed evidence of weathering, and which shows very high in arsenic. It is also very high in arsenic, cadmium, copper, and lead. Next slide, please. Next slide, please. Now, this is the contamination assessment of soil, stream sediment, and mine. From the contamination assessment, it can be deduced that the soil, the stream, especially the soil and the stream sediment, are highly contaminated, or they are highly polluted with these metals. Next slide, please. This ecological risk assessment of soil, stream sediment, and mine tailing. The table shows that the soil, lead in the soil and in the mine tailings, they are quite high. It has a very high potential of ecological risk assessment. And that of cadmium too is high in virtually all the media, in the soil, in the stream sediment, and in the mine tailing. This is still showing an evidence of anthropogenic emission in the environment. Next slide. Heavy metal distribution in plants. Now, the plants that were picked, they are edible plants, plants that virtually everybody in the area cannot do without. And from the slide, you can see that it's only cobalt and arsenic that is not too affected, or that is not found in the plants. Lead is found highly in the plants with zinc, copper, nickel, and chromium. And this is also showing a major problem in the environment if nothing is nothing is done on the environment. Next slide, please.
You have 1 minute, Lanian.
Okay, next slide, please. So this also shows effect of the pollution on the area, and it shows the rate at which plants accumulate metals, which affects man as they eat. Now, next slide, please. So all the tables are showing evidences of high pollution. I'll just conclude. In conclusion, I'll say that the effect of mining in this particular area shows evidence of pollution and evidence of emission of metals into the environment. And since artisanal mining is a major thing that both adults, male, children, and women, they work on, the effects, the metals affect them through inhalation, through ingestion, and through exposure to it. And when all the plants that are taken in that area, which they eat, leads to different kinds of diseases. In fact, this also confirms the work done by Ojukoya. She did something on it in Elisha, and this is also correlating the work that emission of metals through artisanal mining, through illegal mining, affects the environment. Thank you.
Okay, thank you very much. We've had some questions come in. So Adam Sadiq is asking, I'm wondering why you did not also consider mercury, because mercury is also a pollutant which is associated with gold.
Yes, it's not that mercury in the work too was found high, but since I'm particular on, I'm working, my presentation here is on lead. That's why I didn't really say much on mercury. Yes, mercury too is part of accessory metals in lead, in gold.
Okay, I have a question from Gillian Gibson, which is, you seem to have 2 lots of maize, but there is a huge difference between the values. What was the other plant, please?
Sorry, can you repeat the question, please?
So Gillian has asked that you seem to have 2 lots of maize, but there's a huge difference between the values. So what was the other plant?
Yes. Okay, the difference between the values and the maize is because I took it at different locations. One was taken at a location very close to the mining site. One was taken at a location a bit far from the mining site. So it shows the rate of mobility of the metals. So the ones that were very close to the mining site has high metal, while those that are very far from it has lower evidence of lead in the area.
Okay, we have one more talk, Dan. We have a live question from Elikos Dimitriadis. Just allowing him to talk.
Well, I do not like the terminology. Okay, so it was a good presentation, but we have to be careful on the terminology. We don't use mean any longer. Please use the median. And also, we don't use heavy metals. We use potentially hazardous elements for obvious reasons. Okay.
Thank you for the observation.
Terminology.
Okay, thank you for the question. I can't see any more questions outstanding, so I think we'll wrap up. Thanks very much for the questions, and also in particular to the speakers. Thank you for going fast and keeping us on time. Very much appreciated. And we'll move on to the next group of talks, please. Okay, we've got Elikos on mute. Okay, so we're going to set up the next 3 5-minute presentations. So, and then we'll save the questions for the end, unless of course there are some technical issues, and we'll fill the gap with a few questions. So we'll see how we go with this, and hopefully we don't have any technical issues to start with. So we're going to start with Uwe Nurzel, who's based in Germany, and he's talking about the determination of low concentrations of rare earth elements in river water using ICP triple quadrupole in MSMS mass shift mode. So hopefully that will mean something to some of the audience, and for those that it doesn't mean anything, he will provide a quick explanation on what that means. Okay, so please remember questions at the end of these 3 5-minute talks, and we'll give you a 1-minute warning for the 5-minute talks when your time will be up. Okay.
Hello, you hear me?
Yes.
Okay, perfect. But you don't see my video. It's on, but I don't know what happens. So I start, I think it's the best way. So hello, good day everyone. My name is Uwe Nötzel. I'm Atomic Spectroscopy Product Specialist at SEGHLive Technologies in Germany, and today I'm sitting in Hamburg in my home office, like many of you. And I would like to talk about the determination of low concentrations rare earth elements in river water using ICP triple quad technology in MS-MS mass shift mode. The topic is rare earth elements are also known as lanthanides, occur naturally at ultra low concentrations in surface waters. However, rare earth elements are increasingly used in industrial processes and advanced materials such as catalysts, magnets, batteries, television, and smartphone screens. The increasing of use has led to concern about the impact of anthropogenic sources in rare earth elements in the environment. Just a few words on ICP-MS. Single-stage ICP-MS was developed in the early 90s. This became an industry standard. Now it's a very powerful technique. You can analyze up to 75 elements. It has a very high power on sensitivity, so we can go down to sub-PPT levels, and we have a very huge linear range, so you can even measure very low concentrations and high concentrations at the same run. For single-stage ICP-MS, helium collision mode is a very efficient technique to remove polyatomic interferences, and but in some cases it's not enough. Please, the next slide. So when we are taking a look to the rare earth elements, there are some overlaps coming from barium oxide and barium hydroxide on europium, and from barium hydrides on lanthanum. And some of the light rare earth elements, oxides, can interfere on the heavy rare earth element oxides. So we have to discuss another technique to do this. Next slide, please. I stay with ICP-MS, but it is now a tandem MS. So we have two quadrupoles in the instrument, Q1 and Q2. And Q1 can, you can decide with Q1 which ions are going into the collision reaction cell. So you can at one hand reject interferences going into the collision reaction cell. If there's an interference on the same mass, it will go through, but then you have the possibility to do a reaction by a reaction gas. And there are different kind of possibilities. Various gases are possible. It's mentioned on this list. The next slide, please. To use MS-MS and to remove the rare earth element interference, it's good to build oxides. So you can do it with oxygen or with nitrous oxide. We made a check for the rare earth elements. The sensitivity is similar for many elements, but some are much better doing it with nitrous oxide. So this was the decision to use N2O. Next slide, please. This is the schematic of the MS process for this application. So you see that Q1 is open for mass 153, and then with the collision reaction cell, we do a reaction with nitrous oxide, and Q2 is working in mass shift mode. This is plus 16 for the oxide coming from europium oxide. This is going through. So proper interferences at the beginning are rejected by the first Q pole. So thumlin and barium can't go through. Barium oxide has 153 and go through, but will be rejected on the second Q pole. Next slide, please.
1 minute, Uwe.
Yes. So we get very nice results regarding the metal detection limits. We can go down to lowest trace levels, sub-PPT level, as you see here. Next slide, please. Some results. Go ahead, please. One more, please. So these are 4 samples taken on 4 points, and we have the distribution of all the rare earth elements. You can't see really where some anomalia are when we do normalization with PAAS. Next slide, please. You see the anomalia on gadolinium, and when we check very carefully, you see in the uptake in the upstream of the river. This was no gadolinium increase, but it increased after the second point of measurement. And there is some wastewater treatment close by. So this is gadolinium coming from MRI, and this is causes a higher content of this element. Next slide, please. So let me summarize. ICP, MSMS, and mass shift mode is a very efficient technique to measure lowest traces of rare earth elements in surface or river water. We can achieve very low concentrations of these elements. Thank you very much. Next slide, please. Just to, if someone is interested in this application, we have a publication note on this. This is in the mid. This is the 5994-1789. And if you need more information, feel free to get in contact with me or ask questions later. Thank you very much.
Great. Many thanks for your talk, Uwe. If you could just stay around, and we'll have questions at the end of this session, please. And we'll move on to the next speaker, Alex Stewart, who is currently available. Yes, I've seen him there. So ensuring population screening after exposure to environmental toxins, is it worthwhile? Alex,
thank you, Michael.
Thank you.
That's right. Thank you. Okay. That's a question that rises out of a number of these talks already, that there's been a lot of contamination in the environment. Are the people being affected? Next slide, please. And it's useful to do population health screening because the idea is to pick up early disease and go on to treatment. But such programs need some thought. There should be recognized criteria to run the program and an ability to measure and improve quality, and it should be a clear benefit to the community. Next 4, please. You just click them. That's right. So there are 4 things we look at: condition, test, program, and treatment. And we'll take each of these very quickly and have a little look at them. Next, please. And the next one. There are 3 things about the condition that you need to look at. Is there a latent stage, a hidden stage of disease when you can recognize the disease, but when there are no symptoms, so that you're picking it up early? Do we understand the progression of disease, how it occurs, and what happens to it if it's left? And is it actually an important health problem? Because it's not worth doing if it's not. Next, please. Then the test. You need a suitable test that detects what you're looking for and not something else. And you need a test that's acceptable to the community. So, for example, breast screening is uncomfortable, but it's not invasive. And so women are very often willing to put up with a bit of discomfort. It's an acceptable test. Next, please. Screening program itself, it needs to be an ongoing program that will continually find cases and not just a short-term thing. It needs to be economical. It must be at least, it should be cheaper than the cost of the disease progression and the disease treatment. And there should be accepted facilities for diagnosis and treatment. No point in screening if you haven't got facilities for further work. Next, please. And the treatment itself should be accepted treatment, a recognized treatment, a good treatment, and there should be a clear policy on who to treat and who not to treat, because you'll get false positives and false negatives. Next, please. We did a literature review, as at the bottom left, and we found 32 relevant papers. 12 covered the condition, 16 covered the test, another 16 the screening program, and 7 covered the treatment, but only 1 covered the whole aspect and only 3 covered all 4 groups. So very limited amount of information in the literature and quite worrying in some ways. Next, please. So we applied the the work we'd done to 3 situations: to the source, the pathway, receptor, or in medical terms, to the hazard, exposure, and disease. And we chose arsenic, radiation, and lead for these. Next, please. So we looked at arsenic according to the criteria, and We don't know enough about the natural history or the latency of arsenic diseases, although we know a lot about the diseases. And we don't know much about the screening program and very little about the treatments that would be applicable and work. So arsenic doesn't come out very well. Out of the 10 screening criteria, only 4 can we be completely sure about. Next, please.
1 minute, Alex.
Yeah, radiation is better. There's 9 of the 10 are recognized, but only one, but the treatment isn't good to radiation poisoning, because when we detect radiation poisoning, we're not detecting disease. Next, please. And lead is a bit better. Exposure to lead, we know an awful lot about it, but you get lead in the blood, you get lead poisoning, and there's very little we can do about it at the lower levels, which still have serious health effects. Next, please. So putting them all together, there is no accepted treatment for any of these exposures. And this is true over many exposures, which raises serious questions about some of the programs that sit out there and say that they're health screening programs. Next, please. And we need adequate discussion between environmental scientists and public health scientists and clinicians to look further at screening programs. There's new diagnostic techniques coming out for cancers, there's new treatments coming out for cancers. So perhaps we can move forward and improve screening for environmental exposure and do something to help the people in the communities with quality programs that will identify the people with early disease and treat them early and alleviate an awful lot of the issues that arise out of pollution. Thank you.
Okay, many thanks, Alex. If you could just stay around for questions. We'll have the 3 of you back on screen for questions. We'll move to the next speaker, Murtaz Tarek, who'll be talking about geophobias, linking geological events to illogical fear. Sounds interesting. So over to you.
Hey, welcome all. Good morning or good afternoon here. Allow me to extend a warm welcome greeting to all of you. I'm Murtaz Tarek from Egypt, and today I would like to talk about one of the new fields of medical geology, which is geopsychology. I think it will be an interesting topic under the title of Geophobias, linking geological events to illogical fears. Next slide, please. So psychology is a study of the mind and the behavior, and geology can also affect the psychology of organisms positively and negatively. For example, salt caves can play an important role in relaxation and healing from psychological problems, and on the other side, geological hazards, toxic metals, and trace elements can be the cause of many neurological symptoms. Therefore, we can define geopsychology as the interdisciplinary science which is linked geology and psychology with the aim of the investigation of geological factors' impact on psychology. Next slide. The incoming years are likely to witness a considerable development in medical geology fields in order to form unlimited relationships between geology and all medical fields. So next slide. According to that, only very few researchers have addressed the relationship between geology and psychology. So we should fill this neglected area. Next slide. Many of the patients who display disorders of behavior alterations also demonstrate abnormal concentrations of chemical elements within their bodies. So the deviant distributions of soil elements within the blood, brain, and hair of these populations are the primary supports for a connection between geochemistry and behavior changes. In addition, elevations of chemical constituents more frequently reflect alterations in the biochemical mechanism of the patient. So we have a number of elements which are found within the soil and the geochemistry which have implicated in behavior pathologies. For example, we have Tourette syndrome and magnesium deficiency, lithium in water and suicide mortality, restless legs syndrome and iron deficiency, toxic heavy metals associated with autism like zinc or cadmium, copper and schizophrenia, psychology of geophagy and bica, minerals and mood. Next slide. Classification of geopsychology. We can classify this new subfield into 3 categories. First is the natural geopsychology, which studies the impact of natural geological events on human psychology. For example, post-traumatic stress disorder after earthquakes and tsunamis, or phobias related to the geological hazards, which we call geophobias. The second is the geochemical psychology, which studies the relationship between natural and anthropogenic geochemical anomalies on psychological disorders. So we have, as we mentioned above, heavy metals such as lead, mercury, and copper can be the cause or the main factors of many psychological disorders. And the third is geopsychotherapy. And geopsychotherapy depends on using the geosites and geologic materials to treat the psychological disorders. We are closely associated with geotourism, for example, relaxation and healing in salt caves. Next slide.
1 minute, Moataz.
Okay. So phobia is an excessive and irrational fear reaction, and we can associate it with a place, situation, or object. So geophobias can be defined as the phobias related to earth materials and geologic events, including fear of dirt, dust, water, earthquakes, volcanoes, and heights. So we have aquaphobia, which is a fear of water, seismophobia, fear of earthquakes, volcanophobia, fear of volcanoes, metallophobia, fear of coins and metals, claustrophobia, fear of caves. So next slide. In order to use geology and specifically geotourism to treat these rare phobias, a new approach for phobias treatment, and which we call the psychological approach, is suggested. Next slide. That's by setting a treatment program to form a new response to the fear object or even replace the feelings of fear with feelings of amazement. So we can use the features of geological beauty to change the beliefs which have been established in psychopathies for fear of these things. Of course, we need to work with psychologists to set the steps of these programs. So finally, we must work to consolidate the shared research projects in the new branches of environmental geochemistry in order to become more effective and cover many research topics. So the establishment of research teams will be the best form of this collaboration. Thank you.
Okay, a big thanks to all of the speakers in this session. I have some questions now for Uwe, Alex, and Moataz. So I've got one in the Q&A, which is for Alex from Jiandong Li. I'm not sure I understand this question, so we might ask Jiandong to speak out loud if possible. So it says, Alex, are the existing treatment methods known only the doctors, not linked to the environmental exposures in literature? So perhaps
yeah, not quite sure.
So I've allowed Jiandong to talk if
yeah, please.
Hi everyone. Hi. I enjoy about the webinar now. Anyway, if I may very quickly to explain my question, I thinking Alex making good point. We have by environmental geochemist, we know about exposure and environmental contamination. But when Alex referred to the treatment, I thinking probably from the literature review, from our point of view, we may not recognize some of, Alex, you are in a better position. So some of the treatment actually is only considered with the medical field. And the doctor sees the symptom, but they are not related to the environmental exposure. Alex, can you comment on that?
Yeah, that's fair. And we don't necessarily need to know the environmental exposures to treat a patient, but we do need to know the environmental we need to know more about the environment disease link if we're going to identify early disease. So it's not about treating symptomatic people, it's about finding asymptomatic people, people without symptoms, and in the early stage of a disease. So in that case, we need to understand much more about how the disease works, and we need to have proper treatments that work. And the issue is that none of these exposures that we've looked at have treatments that we can completely rely on. Does that answer your question?
I think so, but the gap is between about this medical journal, which actually talking about is kind of whatever physician point of view for the treatment. But you are right, and some of these kind of the subclinical issues we can identify, but some of the kind of like in our available literature may not treat it like linking these two in a good way to putting about this kind of the issue. I fully agree on that. Okay, thank you.
Thank you. Yeah. Yeah, there's a definite need for environmental and medical people to talk together and develop robust approaches in these situations. Dan.
Okay, thanks, Alex. So I'm going to come back to you in a second, but I've got a question here from Moataz from Melvin Otieno, who asks, geophobia arising from fear of agents in the soil, e.g. parasites, how do these compare with geophobias based on the chemico-physical aspects of soil?
I think parasites phobias is more biological phobia based compared to the geological geophobias. But also, if we can insert geology and soil sciences in patients' treatment, I think it will be good.
Okay, thank you, Moataz. And then back to Alex. So this is from, well, there's no name. It's from a Huawei mobile media pad. Hi, Alex. That's a huge and complex work. What is your take-home message to the ordinary person? Ooh, good one.
The simple take-home message is we need to talk more. There's literature about screening projects, but the word they are poorly defined and poorly put together. And when a situation arises and we think, oh, there's an exposed population, can we find out who's been exposed and who's got disease so we can do something quickly and early about it? The answer is yes, we can look at it, but there are recognized ways of doing that, and we tend not to do that enough. So we need to get together and formulate our programs properly.
Okay, thanks, Alex. I have a question here for Uwe from Elliot Hamilton at BGS. Could ammonia be used as a reaction cell gas for REE determination, and how would Q2 be set on mass product ion?
Okay. Ammonia is a gas you can do, but for rare earth elements, I think it's too aggressive. It's better to work with oxygen or with nitrox oxide. This would be the better choice to get a better sensitivity. Of course, if you would use it and you use mass shift, this is plus the ammonia cluster then.
Okay, so that's all the questions I have. Mike, back over to you.
Yes, I'm just checking if anyone's got their hand up. No, it looks as though nobody has a hand up right now, so it suggests everybody would like a brief coffee break. So thank you very much to the speakers in this session, for the last three speakers and before. Very much appreciated for all of your enthusiasm, and we're on time. That's wonderful, amazing. And so we'll have a brief 15-minute coffee break, so please be ready at 3:10 when we'll have Clay Prater from the USA speaking. So he'll be dialing in directly and controlling his own presentation. And then we have a number of quite a varied range of talks this afternoon, and largely focusing on speakers from the Americas to account for the time zone. Okay, great. We'll see you shortly after a brief coffee break, comfort break. I'll do my video as well. Yeah. Welcome back, everyone. I hope you've had time for a coffee or a cup of tea, whatever you need. We're about to start the next session. We're just trying to chase our second speaker, so hopefully Ophelia will be online soon. Otherwise, we may skip the order slightly. So we're going to open with Clay Prater. This is a slightly longer talk, and we'll take questions straight afterwards. And so he's going to talk about landscape controls on nutrient stoichiometry and light availability, regulate lake primary production at the margin of the Greenland ice sheet. Glad I had a coffee to say that. Okay, over to you, Clay.
Hey, thanks, Michael. Yeah, I'm sorry for making you pronounce that long title. You'll see that I've actually knocked some of it out. I think I bit off a little bit more than I could chew with this. So when I was practicing, I was going over time. I wanted to make sure I had time for questions. So I'm not going to talk about energy and nutrients. I'm going to really focus today on changes in nutrient deposition in southwestern Greenland and its effects on lake primary production. And this is some work that I've did for a postdoc that I just finished up at Loughborough University, and working in conjunction with the British Geological Survey and your very own society president, Michael Watts. Okay, so with everything that's been going on in the news lately, you might have missed the fact that we actually recorded the highest temperatures ever, temperature-based measurements in the Arctic and Siberia last week. So this is temperatures getting up to almost 38 degrees Celsius. And I'm in the southern United States right now, and I still haven't felt that heat yet. So this sort of puts an exclamation point on what we've been known for a long time in the Arctic, is that it's warming 2 to 3 times faster than the global average. And this is causing a suite of changes. One of the most striking, I think, is this changes sort of in the melting of the Greenland ice sheet. So last year, over around 90% of the surface of the Greenland ice sheet melted. Let's see, can you see if I can find that? Okay, there we go. And of course, this caused a tremendous runoff of glacial meltwater and delivery of nutrient-rich mineralogenic sediments into the marine environment. And there's been a lot of work showing that this nutrient delivery can potentially cause a really important negative feedback to climate, as primary producers, so photoautotrophs in the systems, will take up this material, fix carbon dioxide from the atmosphere, and bury it down in the marine sediment. So this could be a really important for negative feedback for climate. However, we really have no idea how these changes are shaping the terrestrial environment, because generally most of this work kind of considers this transport, the terrestrial environment is basically just a pathway to the ocean. But we are working down here in southwestern Greenland, which is the largest deglaciated part of the country. So we're really interested in how this is shaping the terrestrial environment. So we know from extensive marine formations in the area that a lot of this material actually gets trapped in the terrestrial environment. And just to give you an idea of how much material we're talking about, this is a large proglacial sand plain, which we work on. You can see some of our kit over here. And this used to be about 80 meters deeper 7,000 years ago. So there's a lot of this material that gets transported to the ocean, but a lot of it also remains in the terrestrial environment. And although the stuff that goes in the marine environment is transported by rivers, so you can see sort of a frozen river over here that's going out to the fjord, most of the transport in the terrestrial environment is happening by wind. So there's really strong katabatic winds that come off the glacier, flow down the valley, and they pick up this material and transport it, deposit it on the surrounding terrestrial environment. So for our research, we're really interested in seeing how changes in physical processes at the ice sheet margin influence lake biology and climate feedbacks. And we do so by studying the elements that sort of combine the abiotic and abiotic processes in this area. Okay, so we're working, like I said, in southwestern Greenland, near the town of Kangerlussuaq, which is a major airport hub for the western part of the country. And you can see in these sort of pink regions here, these are those proglacial sanders. This is the one that I showed you earlier. So there's a lot of sediments in the area, and we've been measuring dust, elemental composition, and deposition rates along this sort of southwestern transect, about a 50-kilometer transect across this area. And we've also been measuring responses in soils and biological responses in lakes. So I'm going to focus on lakes today, as you can see by these sort of dark blue splotches here, that they're really predominant features of this area and in the Arctic landscapes in general. And much like the marine environment, they also are really important sites of biogeochemical processing and carbon burial. So we're really interested in how these are going to respond to changes in our local glaciers here. Okay, so I'll start by showing you some data on dust. I won't go into this really deeply, but you can ask me some more questions later if you'd like. I just want to give you an idea, first of all, of the elemental composition of this dust. So we tried measuring dust elemental composition a lot of different ways, but some of the earliest and cleanest numbers we got were samples we collected directly off the ice. And you can imagine that as the ice melts in spring and summer, this material will fall down into the lake. And since it's composed of a lot of biologically essential elements, this could have a really important impact on the production in these systems. However, not all of these elements leach out. Only the elements that I have here flagged in red, but these do contain some pretty important trace elements, which are essential elements for cofactors for biological enzymes, such as iron and zinc. But for the purposes of this talk, you can just sort of think of dust as having a tremendous amount of phosphorus, which is really important nutrient subsidy for these traditionally phosphorus limited systems. Now, when we look at annual dust deposition, we see a pattern that's very similar to places basically all over the world. Now, most dust work is done in deserts, but it doesn't really matter. Generally, as you get further and further away from the source, you see a decrease in the amount of dust deposition. And we think in our region, this is really tied to wind strength. So there's been a lot of aerial surveys showing that, that the katabatic winds coming off the glacier start to die down right at about 10 kilometers. So after that, you get a decrease in the amount of transport, more dust deposited near the ice sheet. And we think that this, this dust deposition, and remember phosphorus gradient, could have some really important consequences for the local biology. Okay, so we'll get into that now. So we've done a lot of work in the area, and there's some really, there's a ton of really interesting gradients actually leading away from the ice sheet. Light is one of the ones which I won't talk about, but I can talk about during the question session if you would like. But I just want to give you an idea of sort of what's going on in the contemporary environment. And we'll do that by looking at relationships between temperature, nutrients, and primary production. And if you look over here on the y-axis, our metric of primary production, this acronym BSIAR stands for biogenic silica accumulation rate. So biogenic silica is a molecule that's produced by photoautotrophic organisms or algae called diatoms. So they'll take up silica from the water column, fix it in their cell wall, and when they die, they settle out on the bottom of the lake. And we can take lake sediment cores and measure changes in the accumulation of this molecule through time, which is what we did here. For this slide, I'm really interested in contemporary production. So each of these points represents an average over the top, about a decade in the top of these sediments. So you'll see here that as you go further and further away from the ice sheet, you get a decrease in the amount of production. Okay, as you go further away from the ice sheet, we also get about a 250-meter drop in elevation, and this corresponds to around 2 or 3 degrees higher temperature at these sites out here. So lower production with higher temperatures is quite interesting because it sort of goes against the common paradigm in Arctic research that as you get higher temperatures, you should see increased production, and this is typically referred to as Arctic greening. So this tells us we don't really think that temperature is really a direct control on production in our systems, but as I'll show you in a second, we think it has some really important consequences for nutrient transport around the area. So in our mind, we've looked at basically all these environmental gradients, and the strongest one that falls out is this relationship between elemental deposition and production in our lakes, specifically the amount of total nitrogen relative to total phosphorus in our system. And you can see that as you increase the amount of nitrogen and decrease the amount of phosphorus, you get a decrease in production. And this correlates really well with work, sort of bioassays that we've done in the lakes, as well as sort of classical ecological theory and resource ratio theory, which we know that diatoms really need a lot of phosphorus. So they do really well down here in these high phosphorus, low TNTP systems, and sort of decrease in our lakes furthest away from the ice sheet. And this is really suggesting that these organisms out here are phosphorus limited. But again, I'd like to underscore, it's not just phosphorus. If you just look at these relationships with just phosphorus, you don't see one. So it's really the stoichiometry and the relationship between nitrogen and phosphorus that's controlling diatom production in our systems. And this is true for contemporary lakes, and it's also true back through time. So now let me take you a little bit back further in time. So we're going to go down further in our sediment cores, and we'll do so by starting off in our lakes that are furthest away from the ice sheet. Now remember, these lakes are phosphorus limited. So this graph might look a little bit scary and intimidating, but I'll walk you through it. So it's basically just looking at relative changes in temperature, dust deposition, and production through time. Don't worry so much about these numbers on the y-axis. These are transformed for statistical purposes, but I'll just sort of walk you through what we think is going on in the area over the last 1,000 years, okay? So the height of the medieval warming period was around 950 BP. And after that, we can see a steady decline in temperature going into the Little Ice Age, which is in this area here. Okay, you'd imagine that as temperatures decrease, you get advancement of the local glaciers, and as this happens, they release a lot of sediments out onto those proglacial floodplains, which I showed you earlier. Now we know from a lot of contemporary work that dust deposition in the area isn't really related so much to wind. There's always a lot of wind, but related to sediment availability. So as we release more sediments onto those floodplains, we get an increase in the amount of dust being deposited in our lakes, and we've also measured this in soils and peat bogs and stuff in the area. And as you get an increased deposition of this phosphorus-rich soil, you get an increase in the production going on in our lakes. All right, now when we get into the Little Ice Age, you see this little bump here. We get this kind of spike in temperature about halfway through, and a decrease down into the Little Ice Age maximum, or minimum, sorry. And as you get this little bump, you get this decline in dust deposition and a decline in production. Now this period here around 100 BP corresponds to everything that's happened since the end of the Little Ice Age around the 1850s or the 1880s. And we think this is due to extensive glacial activity in the region. During this period, we have glacial retreat, glacial advance, and then another retreat that's still going on today that started around the late 2000s. And all this glacial activity has led to an exponential increase in the amount of dust being deposited in the area, and you see this nice similar increase in production. And
1 minute, Clay.
Sorry?
1 minute warning.
1 minute warning, okay. Yeah. So let me go now to the closer to the ice sheet and just show you. So this is just showing differences in dust deposition and responses in these lakes closer to the ice sheet now. And you'll see, like I showed you earlier, that these lakes are getting much more dust and phosphorus than the lakes furthest away from the ice sheet. But remember, these have really low nitrogen to phosphorus ratio, so it doesn't matter how much dust you give them, they're not really changing as far as growth. But with the arrival, really interestingly, and we see this all over the Arctic, with the arrival of long range nitrogen, which has been transported by North America, this extra nitrogen coming into these nitrogen limited systems has also resulted in a similar exponential increase in production. And when you look at both these lakes together, they've been about a 1.5 to 3 times higher production over the last 200 to 250 years. And remember, just like the marine environments, we think that this could have really important consequences for climate feedbacks. So with that, I think I'll just kind of put up these key takeaways here, but then I want to make sure that I have plenty of time for questions. So thank you for listening today.
Thanks, Clay, and thanks so much for sticking to time as well. It's a busy session. I'm seeing nothing in the Q&A.
Okay.
I don't know if Michael, if you've got anybody's hands up. I have a question of my own.
Okay.
just thinking about people, you know, attendees more in the kind of health disciplines,
Right.
not necessarily in the short term, but in the long term, which communities, either human or animal, do these findings impact most?
Right. So we've done surveys and stuff with the local community, and the health impacts of this we haven't focused on nearly as much, but we have a lot of data on dust particle size and stuff like that. And we know that there's a lot of this is actually dust that will get inside the lungs. It's the right particle size. So we're trying to work with them and just get a basic idea of the frequency and intensity of these dust storms. And we have a lot of feedback from the communities that there is respiratory issues there as well. So we haven't done as much on the elemental side. So we do know that there are some heavy metals in this dust, but it's just sort of more looking at the physical impacts of this dust on the local communities, which is something we would like to look into a lot more frequently, because this is a relatively, I think there's about 500 people there, and they all mostly work around the airport and do some tourism and stuff like that. So yeah, it could have really important consequences. I've got it in my lungs before. It's not fun.
So you've got to do some pretty exciting field work, and by the looks of it, some of the photographs that you've shown.
Yeah.
Is this somewhere you get to visit often?
So yeah, we were going about 3 times a year over the last 3 years, or 3 or 4 times a year. So yeah, we were going quite frequently. And it's just amazing. Every time you go in every different season that you're there, you kind of see something, see something different. So.
Okay, great. There aren't any questions, there aren't any hands up. So thanks very much, Clay. Fascinating talk. And thanks for joining us from the States, and hopefully hang around for the other talks.
For sure.
We'll move on to the next session of fast 5-minute talks. So we'll have 3 talks back to back, and then again 10 minutes for questions after those 3 talks. So we'll start with Ophelia Moulton-Bermeyer, who's now online, and she's going to talk about antimony and other trace elements in blood from children exposed in an abandoned metallurgical area in Mexico. Hello, Ophelia, over to you.
Hello, I am Ophelia Morton from the National University from Mexico. The name from this work is Antimony and Other Trace Elements in Blood from Children Exposed in an Abandoned Metallurgical Area in Mexico. The next slide, please. Yes, we know that mining and metallurgical activities increase the levels from metal in the environment and increase the impact to the exposed population. Very frequently, blood is used as a monitor to evaluate the risk to the communities. In central Mexico, in the 18th century, metallurgical facilities were established to process the silver mineral from the neighboring mining district, and the facilities closed at the beginning from the 20th century, and about 50 years later, the tailing material was reprocessed and to obtain the remaining concentrations from silver and from mercury and from gold. And the waste was left behind. And this material represents now a potential risk for the community. The aim from this work was to evaluate the exposure from the population from this material with very high concentration from metal, especially from antimony and from cadmium. And for this, a sampling campaign was conducted on blood samples from children in the neighbor in Cedral, in this little town, and in environmental media. The environmental media was dust samples and PM 2.5, as well as the tilings samples. You can see here that the 2 tilings places and inside from SEGHLive are within the urban area, and there are about 220,000 tons for material. The next, please. Okay, here in table 1, I show you the metal concentration from the analyzed metals, and we can see that special for antimony, arsenic, and cadmium, we have very high concentration. When we compare this concentration with the recommended values from the Mexican government, we see the special for these 3 elements is very high. The next one, please. Here I am showing the concentrations, metal concentration found in PM 2.5 samples collected in a single place inside from the urban area. We have very high, very high concentrations, and we compare these levels with minimal risk levels for chronic exposure. And we see the special for chromium in this case. We have very high enrichment from metals in the atmospheric environment. We compared the values with results found in PM 2.5 in the metropolitan area from Mexico City, and we can see for all cases we have very high concentrations. Then,
1 minute, Ophelia.
Oof.
What?
Okay, the last one. The last one, another one.
You still have 1 minute. It's okay.
Oh, okay, this one, okay. In table 4, I am showing the metal concentrations found in blood samples from the children in SEGHLive, and we found very high concentration, and we compared this data with other reporting data for other studies, and we see that for most of the cases we have higher concentration. And we compared the results with the pediatric reference values, and we found, especially for cadmium and antimony, we have a very high enrichment from 11 times and 12 times. The next one, please. Okay, as conclusion, we can say that the tailing material does about 200,000 tons from tailings material, very rich in metals, impact the environment, the atmospheric environment, and this high concentration impacted the people living in SEGHLive. And yes, we show very high metals concentration specials from cadmium and antimony in blood sample from the children. Okay, I hope it's. Thank you very much.
Many thanks, Ophelia. So if you can stay online, we'll come back to questions after all 3 of you have spoken, please, and then we'll open questions up to the 3 of you. So we'll move straight on to the next 5-minute talk from Lubika Zupunski, who will talk about exposure to heavy metals from gold mine tailings in South Africa, health risks and research challenges.
Can you hear me now?
There we go. Yes, we can hear you. Thank you.
Okay, thank you very much for this introduction. And I would like to apologize, I don't have camera here on my desktop. So my name is Ljubica Zupunski, and I will talk today about exposure to heavy metals from gold mine tailings in South Africa. Next slide, please. Impact of gold mining activities on human health and environment has been a serious concern in South Africa for many years, and mining activities resulted in significant pollution of residential environments with toxic and carcinogenic metals, including uranium, lead, mercury, cadmium, and arsenic. And substantial quantities of mine tailings were deposited in highly populated urban areas, posing increased risks to millions of inhabitants living in close proximity to the mines. To date, few epidemiological studies have been conducted on association between environmental exposure to metals from mining wastes and health effects, including cancer, in residents living near the tailings in South Africa. Next slide, please. Communities living near the mine tailings can be exposed to metals from the mine tailings through the various pathways of exposure, including inhalation of the dust emitted to the air from the mine tailings, then ingestion of contaminated soil, either through intentional ingestion through geophagia or unintentional ingestion through hand-to-mouth contact. Then another important pathway can be ingestion of the contaminated plants or ingestion of contaminated water. Next slide, please. Besides chemotoxic effects, exposure to certain heavy metals increases cancer risks, and the International Agency for Research on Cancer runs the monographs program with aim to assess strength of the available evidence that some specific agent can cause cancer in humans, based on 3 streams of evidence, and that's on the cancer in humans, cancer in experimental animals, and mechanistic evidence. So some of the metals are classified in the following groups. For the cadmium and cadmium compounds and arsenic inorganic compounds, they are classified in group 1, meaning that they are carcinogenic to humans, with primarily cancer sites are lung, prostate cancer, liver, and skin. For inorganic lead, it is classified as 2A group, meaning that it is probably carcinogenic to humans, and lead as a possibly carcinogenic to humans. And the difference between probably and possibly depends on the strength of the evidence. For mercury and inorganic compounds and organic lead, it is classified in group 3, meaning that there is not enough evidence for classification. Next slide, please. Besides previously mentioned metals, gold mine tailings in South Africa are rich in uranium, and it was estimated that more than 600,000 tons of uranium is deposited in the mine tailings across one of the most exploited basins. For naturally occurring uranium, it consists of 3 uranium isotopes, where uranium-238 starts its own decay chain, and radium-226 and radium-222 are parts of this chain, and are classified as carcinogens by IARC monographs. Also, after internal exposure to uranium may lead to chemotoxic or radiotoxic effects, and if we have prolonged chronic exposure, it may lead to, it is important to do monitoring of the population. And in 2019, Frank Wind et al. Published a paper where they measured the uranium concentration in the hair samples, and they collected hair samples from more than 1,300 individuals. They
1 minute, Ljubica.
Thank you. They measured uranium in 70 composite hair samples, and they got mean concentration between 192 micrograms per kilogram and mean of 122 micrograms per kilogram. And with that level, it was higher. Uranium level was higher compared to other surveys of population. Next slide, please. Next slide, please. Thank you. So previous slide, please. Scientists from International Agency for Research on Cancer and collaborators from South Africa identify research challenges and their study area that is mainly represented by informal settlements, high residential and workplace mobility of the population, and potential disease and cancer under diagnosis and under registration. For the future directions, I would like to say that we plan to set up a long-term multidisciplinary cancer research of protracted exposure to heavy metals and uranium, and to study interaction between them. And next slide, please. I would like to thank to the collaborators from the IARC and the South African Medical Research Council and Northwest University in South Africa. And thank you very much.
Many thanks for your talk. Very interesting. I'm sure there'll be questions later on. So if we just wait for the questions for this session after the next speaker, please, so if you can stay online. So our next speaker is Alistair Kierulf, calling from Canada. His talk is entitled Risky Business. bioaccessibility risk assessments using the continuous online leaching method. So over to you, Alistair.
Thanks very much, Michael. As Michael said, my name is Alistair, and I'm doing my PhD at Queen's University, which is in Ontario, Canada. And this work is conducted with the collaboration of my supervisor, Deanne Boschman, Dr. Iris Coach at the Royal Military College, and also some work done at the British Geological Survey with Michael Watts. If we can go to the next slide, please. So this is just a little overview of what I'm going to talk about today. I'm going to introduce the concept of bioaccessibility for those of you that may not be familiar with it, and the continuous online leaching method, which is a method that we've developed at Queen's for measuring bioaccessibility. And then I'll talk about some experiments that we did at the British Geological Survey in comparison with other bioaccessibility methods. Next slide, please. Do we have the next slide?
It's coming. It's a big image, I think.
That's okay.
You've just crashed it with your figure.
Oh dear, it's a figure of bioaccessibility. Maybe I can describe it. Yeah. Bioaccessibility is a concept of leaching. Yeah. There we go. So it's the amount of a substance that is leached out of a soil particle or food during digestion. And you can see here it differs from another concept of bioavailability in that bioaccessibility is the amount of the substance that is leached out of the soil into the gastrointestinal tract, where bioavailability is that uptake into the blood. And often bioaccessibility is expressed as the percent bioaccessible fraction. So what fraction from the total amount in the soil is leached out? There are many different methods for measuring bioaccessibility. One of them is published by the Bioaccessibility Research Group of Europe, or BARGE, and this method uses artificial saliva, gastric, duodenal, and bile matrices. And this method is very time consuming as it takes up to 5 hours to leach out all of these different, into all of these different matrices. We can go to the next slide, please. So at Queen's, we've developed a continuous online leaching method, which drastically reduces the amount of time needed for bioaccessibility analysis. The way that this method works is our soil is encased in a small mini column and wrapped in glass wool. This is submerged in a water bath at 37 degrees Celsius to mimic human body conditions. And then we sequentially pump saliva, gastric, and intestinal matrices through the sample and directly nebulize it onto an inductively coupled plasma mass spectrometer. Some advantages of the system are it's an enclosed system, which reduces the potential for contamination. Because we're continuously pumping fresh matrix through the sample, it allows for the maximal release of analyte elements, and it takes up to 30 minutes of leaching time for all 3 of these gastrointestinal matrices, as compared to quite a number of hours with the other methods. If we can go to the next slide, it's a profile of the leaching. And so you can see that we get a dynamic leaching profile similar to what is seen with flow injection or maybe chromatography systems. You can see the elements leach out and we can start the next phase right away. And we get an analysis in just over 25 minutes or under half an hour. So we can go to the next slide, please. So I want to talk about some of the work that I did at the British Geological Survey back almost a year ago now, actually. And this was work done in collaboration with Michael Watts and my supervisor, Dr. Boschman. If we can go to the next slide. So this was a comparison between the online leaching method and the method that they use at the British Geological Survey, the BARGE method. And the matrices that were used were saliva, gastric, duodenal, and then bile sequentially for the online method. And in the BARGE method, the saliva and gastric are combined to form a stomach phase, and the saliva, gastric, duodenal, and bile are combined together to form an intestinal phase. And this work was all done on the BGS certified reference material BGS 102, and the percent bioaccessible fraction was calculated using the BGS 102 certificate values. So if we can go to the next slide. This table is quite large, and I'll point out the key things to note, but we were looking at chromium, arsenic, and lead. Unfortunately for the biomatrix of the online method, it was below the detection limit for all of those elements.
1 minute, Alistair.
Okay, and the saliva was below the detection limit for lead. If we can go to the next slide. The key things to note here are the comparison of the stomach phase and the gastric phase between the BARGE and column. And you can see that they were in good agreement with their percent bioaccessible fractions. If we can go to the next slide, please. So the column provides a more rapid bioaccessibility analysis, and we saw that in comparison to the barge method, it was consistent with the stomach extraction data, and the gastric fraction extracted the majority of the elements. Overall, though, there were very low bioaccessible fractions for both of the methods. Future work that I'm doing is to further refine this method and validate it using another method, the US EPA method. If we can go to the next slide. I'd just like to thank MyTax for funding this research, the Queen's Department of Chemistry and the British Geological Survey, as well as all of my group members in the Boschman group. And I'd like to thank you for listening today. Thank you.
Thanks, Alistair. Thanks to the three speakers in this little sequence. I'm going to move to I think we've got 10 minutes or so of questions for the three of you. So I've got a few come through on the Q&A for Ophelia. So this is from Alekos. Were the blood element concentrations in school-aged children spatially related with respect to the source?
Yes, they are related. In the slide I didn't show, I wanted to show you the results from the principal component analysis and all the elements are related. Okay, we tried different ways to show the relationship with the tailings material there, but only copper and iron are not related. Maybe they are related to another sources in the town, another anthropogenic sources in the town, but all other elements are related. And yes.
Okay, thanks, Ophelia. I have another question for you here, which is, thank you for the nice presentation. What about sources of, is that antimony, SB? I'm forgetting my elements, antimony, okay. Antimony and chromium in blood. What about the sources of antimony and chromium in blood, geogenic or those affected more by anthropogenic activities?
Oh, this
is from similar. Tatiana Krupnova, sorry.
Oh, it's similar as the other question. Antimony and chromium, they are very high in the ore material. So they are, I don't remember the values, but they are it's very high in the tailing material too, both elements.
Okay, thank you. I'm going to ask a question myself now to both Ljubica and Alistair. So Ljubica, could you tell us what's the immediate next step for this project in South Africa? Is there something planned to take this a step further?
So the plan is to try to design a protocol for epidemiological studies and for prospective studies, because for now colleagues from South African Medical Research Council conducted a school-based cross-sectional study where they measured the concentrations of the metals and they measured concentrations of metals in the biosamples, air, and for example in the soil, dust, and drinking water. What we would like to do further is to do prospective study, and for that we need a good link with the cancer registry. So really that would be the next step.
Okay, thanks. So Alistair, I have a question for you. As somebody who has done spent some time in the labs abroad at the British Geological Survey, what advice would you have to other early career researchers about spending time in different labs, and how can they get the most out of that experience?
That's a really good question. I would say take every opportunity that comes to you. The opportunity to work at the British Geological Survey was born out of a collaboration that my supervisor found, but I was originally going to go to France to do something, and just, I think being flexible and being open to opportunities really lets you have those opportunities, and they're definitely worth it to take. I know some people were concerned for me that if I went away and did some work away, it would negatively impact my studies. I might have to, take a longer time with my PhD, but it was very worth it, and I would love to go back.
Okay, thank you. And another comment from Alekos to Ophelia. Comment to Ophelia about the use of statistical parameters. Coefficient of variation should not be used. Instead, the median absolute difference should be used. Are you able to comment on that, Ophelia?
We were thinking about this. Thank you for the comment, because it's for our question too. Thank you.
So I think I've seen a few of these questions come through now about which statistic to use. But I mean, surely it depends on the underlying distribution of your data. So you should always do a proper exploratory analysis on your data points, and then that should inform you on which summary statistic you use, I think.
Yes, yes. For the metals, they are very similar. The concentration is very similar. All the children who lived in the town in the same day, they go together in the same school, and the results are not very different for the very high elements.
Okay, so Michael, are you seeing anything on any hands raised?
No, nobody has raised their hand to ask a question. No, so I think that's wonderful. That keeps us on time. So many thanks to the speakers for this session. It's a very interesting discussion and talks. Just as a reminder, the attendees can ask questions by raising their hand, and it's quite nice to have that interactive approach with the speakers to ask questions. So do feel free to put your hand up and ask a question later on. And again, thank you for the speakers in this session. So we move on to the next session. We have Bob Finkelman from the US, who will give us a presentation. He's asking the question, are we in the twilight of coal use? And if so, how will it impact human health? So over to Bob, and you're running your presentation yourself. So this is a longer presentation, this one, 12 minutes. Over to you, Bob.
If you unmute yourself, Bob, and then click on the share screen icon on the bottom of the Zoom window, you should be able to then select the screen you want to share.
Share screen, okay, and whoops, I seem to have lost my, I'm sorry for this. Do you see my PowerPoint coming up? No,
not yet.
It should be a green icon, Bob, at the bottom.
Okay, well, take your time. Give you a moment. If needs be, we can move to the next speakers and come back to you if that helps. So we'll just give you a minute to...
Okay, I think. Okay, do you see anything?
No, just you.
Share screen. All right.
Once you click on it, Bob, there should be another panel which comes up, and you can usually select which screen to share.
I just share, but how about that?
There we go.
Wonderful.
Okay. Do I have time? Do I have time to make my presentation?
Yeah. So you just need to click the icon. That's it. There you go.
Yeah.
All right.
I'll warn you at 11 minutes, Bob.
All right. First of all, on behalf of my co-authors, Michael Hendricks and Amy Wolf, I'd like to thank you for the opportunity to participate in this webinar. We appear to be in the twilight of coal use, and at least in parts of the world, certainly. What I will discuss today is how will this trend impact human health and the environment. Since the Industrial Revolution, and especially since the early 1800s, coal has produced heat, steam, electricity, and in support of modern society. For decades, coal was referred to as king coal, as you can see from these publications, the highway sign, the hotel sign. And this was based on the fact that in the United States, from about 1880 to 1950, coal was the dominant source of energy in the United States and in most industrialized countries. Today, however, we are in the midst of another revolution, a revolution that is attempting to wean coal from our society. You can see for the United States, over the past 15 years or so, there's been a marked drop in the use of coal, primarily to generate electricity. And this trend is continuing to this day. But this trend is not only occurring in the United States, it's also occurring in European Union and other countries. You can see the trend here in European Union, but if you look specifically at a hard coal, bituminous coal, primarily mined in Western Europe, it's a very, very dramatic drop in coal, less dramatic in Eastern Europe, the lighter brown coals. The reason for this dramatic reduction in coal use are many and likely to a large extent to be irreversible. Perhaps the most compelling reason for the trend is the relative cost of fuel. The cost of alternative fuels for generating electricity has fallen below the cost of coal, rendering coal uneconomic, in many regions. As you can see from this diagram, for the first time since the late 1800s, renewables have generated more energy than has coal. And here we're looking at the relative cost of energy. As you can see, coal is more expensive than hydro, geothermal, gas, wind, and solar. And it's less expensive only less than a few relatively minor sources of energy. Furthermore, there's a growing acceptance of the role that coal combustion plays in contributing to climate change and to coal's impact on health and in the environment, resulting in a growing chorus demanding the end of coal use. The aging infrastructure of coal-fired power plants is another factor resulting in closures. As you can see, for the United States, the vast majority of our power plants were constructed prior to 1990 and have essentially outlived their usefulness. Little uptick in 2010, but as of this moment, there is not a single coal-burning power plant planned for construction in the United States. And finally, it's a very significant trend is the refusal of banks and other funding sources to provide financial support for coal-related projects. Consequences, the very, very dramatic drop in the number of jobs in the coal mining sector. And this is continuing down despite President Trump's efforts to sustain the coal mining industry. What are the consequences? Well, first, we have to acknowledge and be sensitive to the massive loss of jobs for the people working in the mines, the power plants, the prep plant workers, transportation, loss of jobs in manufacturing plants and businesses and shops that serve the miners and their families for generations in those communities that were dependent on coal. And another negative aspect is that there's a loss of funds from taxes that would have supported reclamation efforts and a decrease in taxes that were to be deposited in a trust fund to provide support for coal miners afflicted by black lung disease. Nevertheless, there's, of course, some very positive aspects to this trend. The substantial reduction in coal use should translate in significant decrease in respiratory disease, heart disease, asthma, and other health problems attributed to dust generation from coal combustion. This is an estimate a few years ago of the health impacts of emissions from coal burning power plants. They estimated that there was more than 13,000 deaths annually attributed to the pollution from coal, almost 10,000 hospital admissions, 12,000 emergency room visits, more than 20,000 heart attacks, 217,000 asthma attacks, and 1,600,000 lost workdays. All this translated into an economic loss of about $500 million. So recent evidence from the trend in reduced coal combustion indicates some very positive outcomes. A recent study found 55% reduction in lung irritating pollutants and 400 fewer hospital admissions after a single coal plant in Kentucky closed and others added scrubbers. In Central Texas, air pollution dropped sharply after one of the state's largest coal mining operations closed in 2017. Carbon monoxide, nitrogen, sulfur, volatile organics all dropped by nearly 100% in the first year after the closure of that mining operation. And 2020 study found a closure of coal-fired power plants and transition to natural gas across the United States over the past decade saved an estimated 26,610 lives due to reduction in air pollution. What are the other environmental and health issues caused by coal mining and coal loss? Well, one of the big success stories is with acid rain. Back in about 1985, legislation was passed mandating very substantial reduction in sulfur emissions from coal burning power plants. And since then, there's been virtually acid rain damage has been eliminated in eastern United States and eastern Canada. So that issue is already minimized. Acid mine drainage, breached ash ponds, subsidence, damage of structures over underground mining operations, abandoned mine lands, mountaintop removal, uncontrolled fires. Unfortunately, these are some of the consequences of coal mining and coal use. They will still be with us. New problems may disappear, but these issues will still remain. What will substantially decrease is the emission of soot and particulates and the emission of carbon dioxide and its influence on climate change. As coal use is reduced, these issues will proportionately be reduced as well. What about health problems? In addition to the particulates that have affected, as we see, human health, we've demonstrated that emissions of trace elements such as arsenic, fluorine, mercury, selenium, and even minerals such as quartz have caused substantial health problems, particularly in regions where people are using coal in a residential environment. The trend will have somewhat of an impact on reducing these issues, but improved economy, more people turning to electricity, better ovens will dramatically reduce these problems. One issue that will not be impacted by the reduction in coal use is this BEN, Balkan endemic nephropathy. This occurs throughout the world where people are drinking well water that has been in contact with low-rank coals. The water extracts organic compounds, and we believe this helps degenerate the kidneys. Since this has nothing to do with coal mining or coal combustion, this problem will still be with us.
1 minute remaining, Bob.
Thank you. Black lung disease affects millions of coal miners. The closure of mines will certainly improve this situation. But in many countries, coal has been high graded. That is, they've removed the better quality coal and are mining thinner coals and lower quality coal. So this problem will still be with us for some time. All is not well. Global coal consumption has increased in 3 years from 2016 through 2018, primarily because of China, India, Russia. And this diagram that we see here indicates that over the next 30 years, the projection is that we're going to use 40% more coal than we've used in the past 30 years, where we used more coal than we have in the entire history of the world. Coal is a long and profound and indelible imprint on our history, our environment, and our health, and will continue to impact the earth for years to come. So take a deep breath, enjoy the improving environment, but we must maintain diligence and efforts to further minimize environment health impacts of coal mining and coal use. Thank you.
Thank you, Bob. That was a wonderful talk. I have a question here from Keith Torrance, which is, Bob, what about coal for coke production and smelting?
Well, that's still a predominant or a significant use of coal, but a relatively minor use in some countries. In the United States, maybe 1 or 2% of coal is used for coking. We export a lot of that coal to China, to Japan. That is still the most efficient way of reducing iron ore to steel, so that will continue. But it's a rather minor portion of coal. Coking coal is valued at almost 10 times that of steam coal because of its unique properties and its rarity.
So I have a question of my own. A couple of weeks ago, I saw a news article in the BBC which said that the UK had recently gone its longest period without burning coal to generate power. And I think a lot of this was because of the lockdowns from COVID-19. But then as I read a bit further into the article, I saw that what we've actually been doing in some power stations is importing wood pellets from the US. So I'm not sure how renewable this is, and maybe in terms of carbon emissions, it's an improvement, but is it any improvement on exposure to things like, you know, the kind of exposures that come from burning coal? Is that any better with wood pellets or not?
It is. The wood pellets do not have the sulfur. They don't have the potentially harmful trace elements. But the renewables, at least in terms of the wood pellets and similar sources of energy, again, are a relatively small portion of the renewables. This vast majority of renewable energy is coming from wind energy, solar energy, and about, at least in the United States, 10% from hydro. So the biofuels are relatively minor, but yes, they're not, they're only marginally better than coal.
And I have another one from Keith, which is, can you spell out the BEN acronym?
It's Balkan endemic nephropathy. It was initially found in the Balkans, primarily in Yugoslavia, Romania, Bulgaria. But we have found that the same issue in the United States. We obviously can't refer to it as Balkan endemic nephropathy. We refer to it as the lignite water syndrome. But it should, it could, and it likely does occur in any region of the world where people are drinking aquifer, well water, that's been in contact with low-rank coals. So Turkey, Greece are prime examples, enormous amounts of low-rank coals. And many countries around the world do have low-rank coals, and where the aquifers are in communication with them, this degraded kidney situation could exist.
Okay, thanks again, Bob. I'm going to hand back to Michael now.
Am I still on?
Okay, so I will get started. My name is Haley McLeod. I'm a PhD candidate in the Natural Resource Management Department at Lakehead University in Ontario, Canada. My supervisor is Dr. Michael Rennie, and I'm going to talk to you today a little bit about my PhD research, and I've titled my talk, Freshwater Fish Productivity, Drivers, Correlates, and Microplastics. Next slide, please. So freshwater fish production can be defined as the amount of tissue elaborated per unit time per unit area. It encompasses central information such as abundance, recruitment, growth, biomass, and mortality, making it one of the most effective metrics for assessing fish populations and aquatic ecosystem health. However, it has high monetary and effort costs associated with calculating these estimates, which has resulted in a lack of empirical knowledge of drivers and correlates, but also has prevented the application of these estimates in fundamental ecological work such as trophic ecology, energy biomass flow studies, and also understanding the impact of aquatic contaminants at population and community levels. And anyone within the ecotoxicology realm, I think, would agree that there are significant gaps in our knowledge around how contaminants impact both population and community levels, potentially making fish productivity an ideal indicator to study contaminant burden at these levels. Next slide, please. I am unbelievably fortunate to be able to perform my PhD research at IISD Experimental Lakes area. It's a world-renowned research facility located in northwestern Ontario. It has one of the largest and most comprehensive data sets of disturbed and undisturbed freshwater fish populations and the ecosystems that support them in the world. And it's amassed over 6 years of data and is one of the only data sets with the ability to accurately calculate fish production, making it an ideal location for me to be able to conduct my PhD research. And this is an aerial drone shot of the area. Can you go to the next slide, please? Thank you. So I'm just going to briefly go over some of the things that I'll be focusing on during my PhD research. So the first is to explore temporal correlates and drivers through assessing ecosystems that have experienced experimental increases and declines in phosphorus loading, as well as looking at spatial correlates of fish production across a gradient of lake ecosystems that are attenuated by dissolved organic carbon, or DOC. The goal of identifying both the temporal and spatial correlates is to develop a suite of indicators that can monitor fish production more cost and time effectively for the application within industry management and conservation. I also will be looking to understand the impact of aquatic contaminants on the productivity potential of freshwater fish using microplastics as a model. So I'm quite excited to be starting a long-term exposure this fall, looking at both how microplastics, the physical and the chemical components, impact egg and larval stages of lake trout, and then looking at how that changes the recruitment and production of a population, both through using life history endpoints and looking at the proteomics as well. Next slide, please. So I'm going to talk a little bit about some of my preliminary data that I have, specifically that shows some evidence that phosphorus may be a driver of fish production. So in Lake 375 at the experimental lakes area, an aquaculture experiment was conducted from between 2003 and 2007. And phosphorus levels increased to 5 times the background levels during this time period. There is quite a substantial amount of literature that has been published on this experiment, and it's really quite interesting if you're interested in looking at it. I specifically have been looking at understanding how lake trout production changed during this time period. So you can see in the left-hand figure that production did increase quite substantially during aquaculture, and aquaculture is indicated by the shaded region on the figure. To understand where this boost in production came from in lake trout, I've been exploring different things within the population, such as recruitment, which you can see on the right-hand side. So recruitment was highly increased during that time period, again denoted by the shaded region on the plot, which is really interesting. And I've seen really large shifts in maximum size within these cohorts, as well as substantial increases in adult size in fish, which is not a very common phenomenon to see. I just wasn't quite ready to show that today, but I am looking forward to being able to explore this a little bit more going forward. Next slide, please.
1 minute, Hayley.
Thank you. So overall, my PhD research will be able to result in the development of time and cost-effective tools to evaluate freshwater health and fish populations efficiently. I'll also be able to provide important information around the impacts of microplastics on freshwater fish populations, but also look to use it as use productivity as an indicator for contaminant burden, and ultimately improve the current state of knowledge of freshwater fish production and the ecosystems that support them. If anyone has any questions or comments, please feel free to email me at my underlined email. And just my next slide, please. I just want to acknowledge all of my funding partners and obviously those who have supported me, because without them, I would not be here. So thank you, that's everything.
Great, wonderful. Thank you very much, Hayley. Interesting talk. We'll come back to you after the next talk. So if you just stay online, we'll have the questions together. So we'll move quickly on to the next 5-minute talk from Melvin Otieno in Kenya. So rapidly traveling across the world. So Melvin's title is Effect of Nutritional Content of Both Commercial and Non-Commercial Feeds on Aquaculture Fish in the Wynnum Gulf of Lake Victoria. Over to you, Melvin.
Okay, hi everybody. My name is Melvin Otieno, as Michael said.
Are you sorry, Melvin? Are you able to speak up or adjust your microphone slightly?
Yeah, can you hear me?
Bit louder. Go on, big voice.
Okay, can you hear me?
Go on, go for it.
Okay, my name is Melvin Otieno from Kenya, and my research topic is effect of nutritional content of both commercial and non-commercial feeds on aquaculture fish in Wynnum Gulf of Lake Victoria. And my supervisor is Dr. Andrew Marriott and Professor San Odipo. Next slide, please. My introduction. Feeds are critical to the success of aquaculture on Lake Victoria, and aquaculture has a potential to address food insecurity among the riparian communities in the lake region. And aquaculture farmers are addressing the fish feed challenges by using locally sourced feeds, but without knowing their nutrient composition. So in my research, I've been looking at the quality and the element content of in situ feeds and the commercial feeds, and also the element level from these feeds and their effect to the quality of the aquaculture. Next slide, please. For my methodology, the in situ feeds included Caridina, Niloticus, and the Rastonobola argentea, the omena. And for the commercial feeds are the pellets. These feeds were collected from the local aquaculture farmers in the Lake Victoria region and prepared at the University of Eldoret. Analyses were done at the British Geological Survey, and the trace elements that I was looking at were the essential elements and the toxic elements that included lead, mercury, and cadmium, which were assessed. And as the picture shows, an example of an aquaculture cage that we sampled. Next slide, please. If you look at the results, the essential macronutrients and the macronutrients in feeds were analyzed, and you find out that the different feeds omena, the shrimp, and the pellets contained comparable mineral content, and occasionally there are higher levels of macronutrients in natural feeds than the commercial pellets. For example, if you look at the calcium and iron, they were at a higher level. And also the pellets containing the mixed feed was more variable in the micronutrient levels. Next slide, please. And then for the toxic elements, we found out that Caridina niloticas were highly abundant in the lake. The tilapia fed mostly on the shrimps. However, the elevated levels of aluminum and chromium and lead were observed in the Caridina niloticas tissues. Next slide, please. We are also looking at the essential micronutrients and macronutrients in the fish muscles, whereby we were comparing the caged and the wild fish. And as a result, there was no significant difference in microelements in their muscle tissues. And also the macro element levels, for example, in calcium and phosphorus were significantly higher in the muscle tissues of the caged fish as compared to the wild fish. Next slide, please. And also in the toxic elements in fish muscles, you find out that there were high concentration of toxic elements in both the caged and the wild that are below the thresholds. And also some toxic metals were elevated in wild fish.
1 minute, Melvin. You have one minute left.
Okay, elevated levels in wild fish could be the result of more varied diet compared to the caged fish. Next slide, please. In conclusion, there was the potential use of in situ products that is the Caridina niloticas and Rastemobola agintia are a sustainable source of aquaculture in the lake. And our study presents a possible sustainable means of access to in situ feeds in the lake for aquaculture farmers. And aquaculture offers a potential to address food insecurity and hidden hunger issues in Kenya. Next slide. Thank you. Thank you very much. And I would like to appreciate the funders and the collaborating institutions for supporting my research. Thank you so much.
Thank you, Melvin. So now we have 10 minutes of questions for the two of you, both Haley and Melvin. So I've had one come through on the Q&A from Gillian Gibson, who says, Haley, were you evaluating farmed fish or natural fish?
Yeah, so I was only evaluating natural fish. So these are the natural populations. And the farm fish were essentially just placed there just to see what were the impacts of aquaculture. And within that experiment, we monitored white sucker, lake trout, a variety of different minnow populations. I believe there's also research done on both the zooplankton and phytoplankton communities as well. So it was actually really quite comprehensive.
You mentioned microplastics, and I wondered if there's any evidence of negative health effects of humans eating microplastics in fish.
So from my knowledge, I don't believe that we've really assessed that yet. And also based on the literature, I think the concern would be more about the transfer of chemicals into humans. So microplastics have chemicals that are added to them during the production process, but they also have the ability to accumulate a variety of different concerning chemicals like PCBs within the environment. And then obviously that can be amplified through consuming fish and also could be leached from the microplastics through consumption. Because the microplastics are able to translocate into muscle tissue as well. So it's very possible. And what we are seeing too is that, and something that's a little bit missing in the literature right now, is that there are nanoplastics and those do exist, and that has the ability to actually directly enter cells. So there needs to be more research done on that and how that is potentially transferring chemicals from the environment and into fish and also humans.
Okay, I have a question here from Grace, from Melvin. If we start using omena to feed caged fish, are we not going to enrich a few people and create high levels of food insecurity? Omena is cheaper than a large fat tilapia here in Kenya.
Okay, answering that, according to this research, we've seen that the use of locally available feeds are of great value. So I think that would be a nice solution for the aquaculture farmers to basically use the in situ feeds the natural ones. That's the omena.
Okay, and then I have my own question for you. Oh no, sorry, I had another one come through on the Q&A from Felix Onyije. Good presentation, Melvin. Did you look at the histopathology of the mussels to see if they agree with your analysis of toxic elements?
No, I didn't look at that.
So perhaps that's something the two of you could maybe
Yeah,
get together on to, maybe we've got a collaboration there.
Yeah, maybe that would be nice.
And then my own question to you, Melvin, thinking
Yeah.
about short-term solutions to these kind of pollution problems, is there any way that you can cook the fish differently that would remove toxic elements?
Yeah, there is a way we can cook just by maybe simply boiling it. Perhaps it can be helpful for that.
Okay, Michael, I'm not sure if you're seeing anything on the...
No one is raising their hands. No. No, so I think that brings us to the end of the session, doesn't it? So many thanks to the speakers in this session. And I think, Dan, you're going to do a wrap-up of the day. I've got a few things I'd like to say after, if that's okay. And I think Bob Finkelman from the US would like to say something to the Americas group. If you want to wrap up for the day, if people want to ask questions from the whole day, please do put your hand up using the icon. Over to you, Dan.
Yeah, so before we open up for a kind of wider discussion, I just wanted to extend our thanks really to all of the speakers for today. It's a bit of a new format. It's very quick, fast-paced. I think everybody's really stepped up to the plate, and thanks to everybody for sticking to time. I think it's worked really, really nicely. The topics that have been covered today have been very diverse. I think we wanted to really mix themes into the same session to keep people interested throughout the whole session, rather than having individual sessions for individual disciplines. And I think that's worked very well. But of course, we'd be happy to get your feedback on that for planning future events. Obviously, a big thanks to all of the attendees. This was something that we really started planning properly only about a month ago. And as Michael said earlier, we've had over 100 people register for the event from 35 different countries, which I think really highlights the diversity of membership that we've got and how international we are as a society, which is really one of our strong points. And then thinking beyond just today, you know, this has been something that we plan to try and get the society together and keep us connected when we've got these restrictions because of COVID. But actually, it showed us that I think it's a successful format that we can use for future meetings, maybe more regularly, especially given, you know, additional pressures that we have now to keep our carbon footprint down with the threat of climate change. And we only really have one big international conference per year. And I think that this is something that we could really think about doing more regularly, maybe smaller, more specific meetings or even regional meetings. So yeah, again, just a thanks to everybody. And I think I'll hand over now to Bob Finkelman, who was going to say something about the Americas region. We need to allow Bob to speak, I think.
Yeah, it's just happening. Just need to unmute. You just need to unmute, Bob.
Okay.
Yeah, we've got you.
Okay, I will learn this system. I want to apologize for fumbling at the beginning of my presentation. I thought otherwise this was an excellent program. I really feel very comfortable that this type of session could turn out to be quite beneficial, quite popular. Two things I'd like to mention. First, the SEGH has now co-sponsored a technical session at the Geological Society of America that's scheduled for October 25th through the 28th. It's going to be a teleconference. It's a jointly sponsored session with the GSA's Geology and Health Division, and it will have, I think, a lot of presentations that would be of interest to SEGH members. And I just want to remind everyone of one of the items that appeared earlier. We're planning another of these SEGH live sessions, or maybe, depending on circumstances, an honest to goodness conference in Canada, August 2021. So I look forward to hearing from all of you at both the GSA and the SEGH Canada conference. Thank you.
Great, thank you, Bob. Just a few things to add for today. Yeah, we're obviously trying to build membership in various areas. So if there are groups you want to build in your countries and you'd like to run some initiatives such as short meetings, do say, and we'll try and support you. So just make sure you take a note that for tomorrow the Zoom ID changes and you have been emailed the ID for tomorrow to access the meeting. Okay, so we start earlier tomorrow at 9 AM to allow for Asia to present talks. For those in the Americas, we are recording them so you can access the recordings behind the SEGH members login area on the website. A little bit of news today. Springer have offered prizes for best talks from early career researchers. So if you haven't made it known to us that you are an early career researcher, how do I've lost the, let me share my screen. Can I do that? Yeah. So let's go over here. Yeah. So Springer are the publisher for environmental geochemistry and health. So they've offered prizes of $250 first prize and $150 runner-up. So if you are an early career researcher and you haven't made it known to us, please do let us know. You can see the wrong screen. Bear with me for the screen because I'm only going to show this shortly. Springer have also announced that they have picked out 10 ECR papers from the journal in 2019. So they're offering a prize of $300 cash to the best paper. So currently the SEGH board are voting on the best paper of 2019. And don't worry, the voters are drawn from quite a broad spectrum of backgrounds. So do let us know if you are an ECR for this meeting. There are book token prizes of $250 and $150 from Springer. The other news from Springer, you just saw the slide flash up, is that we have our new impact factor score for environmental geochemistry and health. So it has gone up. So this year it has gone up from 3.25 to 3.47. So that's a pretty healthy rise. And you can see over the last, over the previous 4 years, it's risen pretty steadily. And in terms of citations, they've pretty much doubled as well to 4,500 a year to 2019. And over that time period, you can see we were getting in the high 300s to 400 papers submitted to the journal in 2015. And last year it was something like 950. Now, 20% of papers are rejected, but that's quite a big increase in submission of papers, largely from Asia. And already up to the end of May, about 500 papers were submitted. So currently Springer are trying to clear the backlog of papers going into issues, and will move away from issues to ad hoc publishing, which will improve the turnover rate of papers. So from submission to publication should be much faster in the future. So I think what we will do is cover some member information at the general meeting tomorrow. We can't capture everyone at midday, but we have drawn comments from a recent board meeting, so we'll share those. We'll share some information about the structure of SEGH and how it works and future initiatives tomorrow afternoon. And I think that really Screenshot. Oh yes, Olivier's just reminded me of something where what we hope to do is take a photograph of delegates, as you would at a conference, is actually take a photo of everyone on camera. So if everyone's okay with that, we'll put everyone on screen and we'll take a screenshot, and that will be our conference photograph for today, and we'll do the same for tomorrow.
Dan, if you could just help me promote everyone to panelists.
So we're just going to convert you to panelists so that we can see you on the screen. So if you bear with us, it'll take a lot of going through to convert everyone. Get your smile ready, slick back your hair, tidy your hair. Tidy the bookcases behind you. Well, there we go. We can see a few people arranging their hair. That's very good. I think somebody's just opened a window with a nice scene behind them, a nice beach. Make sure your lighting is okay so that we can see you. Let's see if this works. So we have a lot of, the attendees are rapidly leaving, are they? They don't want the photograph taking.
No, as we promote them to panelists, they drop off the attendees list.
Oh yeah. We're at about 60 attendees, so we've ranged between about 65 and 85 today, and we had a bit of a drop off from Asia. I think as it's quite late in Asia at the moment. We're almost there. So get your smiles ready. Are we going to give them a warning, or should we just do a practice photograph and catch them out?
I think we've got three pages of people, so we need to do a couple of different screenshots.
Are you ready? Your best smile. Cheese. Or whatever you say in your language. Ready?
Screenshot as well.
Doing screenshots now.
If everyone can smile.
Ready? Cheese.
Keep smiling. Smiling.
Quite a few people not on screen. They're shy. See how long you can hold the smile for.
Keep smiling. Let's double check that we got some photos.
All right, that'll be $15 per photo, please. That's joking. Okay. So we have an open floor. If anyone would like to ask questions, perhaps Dan, you can fill these. Does anyone want to comment on the day? How can I see? So we just need you to
unmute yourselves.
Raise your hand, or you can just unmute yourself and ask a question. Or make a comment of the day. The photos are finished. You can stop smiling now unless you're really happy for the day. You can rest your face. Finished, didn't you?
Yeah, finished.
Yeah.
Can people unmute themselves, or do we have to unmute them?
I think people should be able to unmute themselves if they want to comment. Please.
I think Keith has unmuted himself.
I can see a hand up. No.
I was just going to say I thought the talks were all excellent and it was really worthwhile event. I really like these kind of Zoom meetings. I think they're very good for the presenters, and they're good for the people that are participating in the event. So thanks for putting this together.
Well, thank you to all of the speakers and for the enthusiasm and the energy. It's a new format to get used to. Would anyone else like to? Oh, we have one. Noor, if you unmute yourself.
I do.
Good to know.
Okay,
Hello, Michael,
I just want to say thank you very much to give us the opportunity to see so many familiar faces. So delighted to see you guys.
Keep chatting. Let's go to Noor.
Hi. I enjoyed to participate in this meeting. It was really good. Congratulations to the organizing committee. They did a really good job.
Does anyone else have something to say? Something they'd prefer to see? Or we do have another day of talks. I see. Who has the Huawei Media Pad? It doesn't give your name. You're waving your hand.
Hi, Michael.
Hello.
I see Chemikos from the University of Zimbabwe. This has been a very fruitful interface. Thank you so much. Keep it up.
Do we have anyone that wants to volunteer and run one of these in the future? Whose hand did I see go up there? It was very fast. Okay. Anyone else would like to make a comment or speak? Was that Belinda? I'm having to flash through screens because there's so many of you. So I apologize if I miss you. Don't just throw your hand up quickly and drop it. Just hold it up. Okay. I think we are pretty much. Oh, there we go. Saeed.
Oh, hi, Michael. I would just like to congratulate you and your team for organizing this, because I know we are all, the whole scientific community is away from each other due to COVID-19. We can't be coming together. So thank to you, Olivier and Dan Middleton, for putting this together. It's great. Thank you.
Okay. Okay. All right. I don't see anyone raising hands. If you are desperate, then shout out. All right.
Yeah, we have one more, Mike. We've got one more. Huawei Media Pad.
Oh, University of Zimbabwe, yeah. Okay, Zimbabwe. No, he's waving.
Hi, Michael.
Oh. Go on, what would you
Can
like
you hear
to
me?
say? Yes.
Thank you very much. I'm having connectivity problems, but it's been a very fruitful interface. Please keep it up. Thank you. See you tomorrow.
Okay, thank you. Just remember, these are recorded, so if you have had internet connection problems during the day, you can pick up some of the talks. I'm not quite sure when we'll have the talks on the website, but give us until next week. They may be on the website before then, and you can access the talks later on. Okay. And I think if no one is waving their hands or shouting out, unless Dan or Olivier, do you want to say anything before we?
Thank you everyone for coming today, and look forward to seeing you all tomorrow.
Dan?
Yeah, thanks everybody. See you tomorrow.
Great, thank you. We'll see you tomorrow morning. Take care, have a good evening, morning, afternoon, and we'll see you tomorrow. Take care, bye-bye.
Bye, thank you.
Bye.